So dear students, in today's lecture we are going to see about a design of an L-beam. So the given problem is we need to design an L-beam for an office floor, and they have given the following data. That is, the clear span is 8 meter and the thickness of flange is 150 mm, and they have given the live load acting on the slab as 4 kilonewton per meter square. So we need to convert this live load on the slab to the live load on the beam, and they have given the spacing between the beams is 3 meter, and they have given the column size as 300 by 300 mm. So, and we need to use M20 grade of concrete and Fe415 grade of steel. So as usual, the first step is we need to find out the dimensions of the beam, that is dimensions of beam. As I have already told you, so if you are going to solve a flange beam, first we need to draw the diagram. So let us assume a office building like this. So here one beam is here, another beam is here, likewise it is going to continue. So the spacing between the beams, that is the spacing between these two beams, let us assume it is from the center of this beam to the center of this beam, that is 3 meter. So here if you see this beam, if you take the edge beam, so it will act like an L beam, because only in this side, that is on the left side only, we are having a beam size slab, and in this, if you consider this beam, it will have slab on both left and right. So it will act like a T beam, and this will act like an L beam. So if you want to design the L beam, we know that half of the load will go to this beam and half of the load will go to this beam. That is, half of this load from this slab will go to this beam and this beam. So let us consider this is the half portion. So this load will come here and this load will come here. So in this way we need to design. So first step, they have given the clear span and they have given the thickness of flange. So we need to find out the depth of the beam, that is effective depth. So we need to use the formula L by D ratio. So let us assume this beam is fixed. So let us consider fixed beam, because we have always doing simply supported. So now we are going to do a fixed beam condition. So if it is a fixed beam, so it will come under the continuous beam. So if you take page number 37 of IS 456, here if you see for continuous, they have given the value as 26. So I am going to take L by D as 26. So L by D equal to 26, page number 37. So if I am going to use L by D value, so we know that we need to calculate D. L is 8000. So divided by 26 is equal to, so the value is I am getting as 307.7 mm. So I can consider the D as 310 mm and overall depth equal to 335 mm, because we are assuming the cover as 25 mm. So we have calculated this value. Next step is we need to calculate the B effective, because they have given the value of flange width, that is DF equal to 150 mm, and they have given the support, that is column size, because since this beam is going to rest on the column, so mostly the B is equal to 300 mm, because mostly we will have the same size of that of column. So we can say that, assume that BW equal to 300 mm. Next we need to find out the BF, that is effective width of flange. So in order to calculate effective width of flange, we need to use the formula which was given in page number 37 of IS 456. So here if you see, to calculate the value, we need to use L beam, BF equal to L0 by 12 plus BW plus 3DF. So what I am going to do is BF equal to, I am going to write this formula. So here if you see, the formula is BF equal to L0 by 12 plus BW plus 3DF. So this is in page number 37 of IS 456. So simply you know that the L0 is nothing but the value, actual value, which I am going to take. So here if I want to calculate L effective, I can calculate L effective, but I need to use only 8000, because in this condition they have given the clear distance between the to the adjacent beams, that is the clear distance will be L0 is 8000. So I am directly taking that as 8000. So 8000 divided by 12 plus 300. plus 3 into 150. So if I am going to calculate this, then I am going to get the value as, so the width of the beam. So the width of the beam at the bottom, that is the web width, will be equal to the column size, because most probably we will rest the column, we will rest the beam on the column. So if you want to consider the width of the beam, then we need to consider the same as the size of the column. So I am assuming BW as 300 mm. Next I need to find out the effective width of the flange. So in order to calculate the effective width, I need to calculate the value of this by using this formula which was given in page number 37 of IS 456. So the value is BL0 by 12 plus BW plus 3DF. So BW is width of the web of the web. BW is width of the web and DF is depth of the flange. L0 is nothing but the distance between point of zero moments in the beam. Since this beam we have assumed it as a fixed beam condition, so we know that if it is a fixed beam, then the moment will be zero only at the center to center distance between the beam, that is effective length. So the effective length formula is, we know that L effective equal to L plus D. That is, here if you see, the D is 335 mm. So I am taking it as 8.31 meter. And another one is, we know that L plus center to center distance, that is L plus support width. So L plus support width. So here if you see, L is 8 and support width is 0.3. So it is 8.3. So I am taking it as, we know that the least of this need to be taken as L effective. So I am taking it as 8300 by 12 plus 300 plus 3 into 150. So the value which I am getting is 1441.67 mm. So I can directly take it as 1440 mm based on this condition. Next one is, we know that it should not be greater than BF equal to BW plus half of clear distance between beams. Half of clear distance between adjacent beams. So this condition was given in page number 37 of IS 456. Here if you see, but in no case greater than breadth of the web plus half the sum of clear distance to the adjacent beam. So we are using this formula, so which was written here, BW plus half distance between the adjacent beams. So here BW is 300 mm plus half into value is 3000, because clear distance between the beam they have given is, say, spacing between the beam is 3 meters. So I am taking it as 3000. So here if you take, the value will be 1800 mm. So always we need to take the least of the value. So BF, that is width of the flange, is 1440 mm. So I have calculated the value, that is, these are all the dimensions. Next step is, I need to calculate the load as usual. Next step is load calculation. Load calculation. So self weight of slab. So self weight of slab is 1 into depth of the slab is 0.15 into 25. But here if you see, it is not a slab. We need to convert this load to the beam. So we know that the spacing between the beam, because which was given is, spacing between the beam is 3 meter. As I already explained, half of the load will come to this L beam. So this is going to be our L beam. So this is going to be the T beam. So in order to have the value on this L beam, we need to multiply it with half of the value, that is 3 by 2. So what I am going to is, I am going to convert this or multiply this with 3 by 2. So if you solve this, we will get the value as 5.625 kilonewton per meter, because the slab load is getting converted to the load on the beam. Next one is, we need to calculate the self weight of beam. So self weight of beam, so then we know the value. So we know that the width of the beam is 0.3 and depth of the beam is 0.335 and the length is 1 meter and unit weight of concrete is 20. So value is 2.513 kilonewton per meter. Next we need to consider the live load. So live load on the slab they have given is, if you see here in the problem, they have given the live load on the slab is 4 kilonewton per meter square, but we need to convert that live load as live load on the beam. So we need to multiply with the area of the, that is the width which is going to act. So if it is 3 meter, half of the load, so the value will be 1.5 meter. So here if you see, I am going to consider this as 4 into 3 divided by 2. So the value will be 6 kilonewton per meter. So next I am going to consider the floor finish load. So floor finish load, the value will be, as usual, since it is a beam, I am considering it as 1 kilonewton per meter. So the total load acting on my beam is 15.138 kilonewton per meter. So this is my working load. Next I need to calculate my ultimate load. So ultimate load equal to, so the value is 22.71 kilonewton per meter. So I have calculated the load. Next step is I need to calculate the bending moment. So since it is an L beam which is going to get subjected, so if you are going to consider this area, this beam, so it should be drawn like this. So here if you see, so it will be my beam and it is going to be supported on a, or it is going to support a slab like this. So let us consider this will be the distance, that is this will be my 1.5 meter, because center to center it is 1.5 meter, because I have only taken the half of the portion which is going to, or the load which is going to act on this particular beam. So if you see here, only we are having the beam slab on left side, so which is going to induce a twisting moment. So if you are designing an L beam, in addition to bending moment and shear force, this beam is going to get subjected to torsion. So in L beam, in addition to bending moment and shear force, torsion will also act. So we need to design for torsion also. So if we are going to consider the design, first we need to calculate the bending moment due to the load acting on the structure. Since it is an fixed support condition, so the bending moment mu will be considered as WU L square, that is L effective square divided by 12. So we know that to calculate the bending moment we will use the formula WL square by 12. So the value here we are getting is W is, so the value is 130.37 kilonewton meter. Next VU, that is shear force, VU equal to WUL divided by 2. So the shear force which we are getting is 94.25 kilonewton meter. So if you see here, this moment will happen at the support. So next I need to calculate the moment at the center. So moment at the center, the formula is mu equal to WU L effective square WL square divided by 24. So how we got that value is, we know that if you are considering a fixed beam like this, then the bending moment will happen like this. So here it will act like a simply supported beam. Here we will have the value. So if you need to calculate the value, we need to nullify both the values. So WL square divided by 8 minus WL square divided by 12. So at the center we will have this moment, and at this point we will have this moment. So if you nullify this, then we will get the value as WL square divided by 24. So which I have used here. So if you substitute this, then the value will be 65.2 kilonewton meter. This will happen at the center of the beam. So we have calculated the moment and shear force. Next we need to calculate the torsion. So in order to calculate torsion, we need to use the formula which we have in codebook. So before going to calculate the torsion based on the moment, we need to know how a twisting is created in my L beam. So if you see here, this beam, let us consider the slab is going to carry an UDL. So this UDL, if you see here, I have written it as 12.625. But if you see here, it is 15.138. Why I have written this is because we are calculating only the load on the slab. So the load on the slab means we need to omit this self weight of the beam. So here if you calculate the remaining value, 6 plus 1 7, and the value is 5.625, that is self weight of the slab. So total value is 12.625. so that is the load which is going to act on my slab, and due to this load we are going to have a twisting because we are having only slab on the left side. So due to this, it will have a tendency to rotate the beam towards the left side. So it will create a twisting. So next we need to calculate the what is the twisting load or torsional load on my beam. So since we are told that in addition to bending moment and shear force, torsion will also act, we need to calculate how a torsion is induced in our L beam. So if you see here, this beam is having only slab on the left side. So and we need to consider the load acting on the slab alone, that is load on slab. So I need to include my self weight of the slab, that is 5.625, plus live load acting on the structure 6, and floor finish. So the total value will be 12.625 kilonewton per meter is the load which is acting on my beam. And here if you see, we know that the spacing between the beam is 3 meter, and we have taken the impact on this beam, that is the portion of the slab which is going to create impact on the slab is 1.5 meter. But see, if you see this, we have calculated the B effective value. Here if you see, the B effective value is 1440 mm. So in this 1500 mm, only this 1440. So if you are considering this value, so this will be, this 1440 is my actual area which is going to be act as a L beam. So here if you see, I need to consider only the portion of the slab which is going to be the slab. So I need to minus this 150 mm. So in order to calculate the center of gravity, because if you are considering this region, so this total, this will be my 150 mm. And if I am going to calculate the load acting on the structure, so then I need to consider only this portion, because from the center of this point to this portion which is going to be the value. So in order to calculate this value, I am going to calculate this centroid. So centroid of slab. So here if you see, I am going to consider 1440 minus 150 mm divided by 2, because we know that from this area to this area, that is if I am going to consider this value is nothing but 1440 minus 150 is going to be this value. So in order to calculate this value, I am considering 1440 minus 150 divided by 2. So half of this value will be this value. So the value which I am getting is 645 mm. So in order to calculate the moment, we know the load and we need to multiply with this perpendicular distance. So the load is going to act like this, and this is going to be my perpendicular distance. So what I am going to do, I am going to calculate the torsional moment. So torsional moment will be equal to load, that is 12.625 into distance 0.645. So the value which I am getting is, so that to calculate torsional load, I am multiplying this load, because we know that torsional load means it's a twisting which will be a moment. So load into distance. In order to calculate this value into an ultimate value, I am multiplying it with 1.5. So the answer I am getting 12.21 kilonewton meter, because it's a twisting. So I am considering it as torsional load. Next I need to calculate the torsional moment, which is going to be load into perpendicular distance. So here if you see, I am going to multiply this 12.21 into my distance, that is 8.3 meter. So WL by 2. So half of the distance, what is the moment? So here the value is 50.67 kilonewton meter. So here if you see, we can write this torsional load, or we can write it as torque, TORQUE, torque.